Well, hopefully you did well on your quiz. Students in here did very well. We did grade them in class just a moment ago, and they did fantastic. So hopefully you did as well. It does help a little bit when there's not a whole lot of math to have to worry about. Speaking of math, I want to kind of get you prepared to study tonight for test 10. Test 10 coming up, not this next lesson, but the lesson following. So if you'll jot down this information as you prepare to study this evening, and of course you'll be studying tomorrow night as well. Test 10 does cover chapters 16 to 18. Test 10 does cover chapters 16 through 18. By the way, there will be no new information after this test. We're going to review and take the exam, which covers chapters 13 through 18. So this wraps up both test material and exam material. But we're going to take this test, helps to offset the exam a little, also help to offset that chapter 13 test. It tends to be a hard one by getting an extra test in this course, so 3 tests plus the exam. So chapters 16 through 18 on this test. I want you to get some equations to know. As you're looking over, of course, terms that you can study without me. But I want you to be able to focus on what type of math to be looking over. So chapter 16, equations to know. First of all, V equals lambda F. V equals lambda F. Wave speed equals wavelength times frequency. Knowing, of course, that wave speed will be in either meters per second or feet per second. Because lambda class, which stands for wavelength, will be in either feet or meters. Frequency, of course, class measured in hertz, which means per second. But we would write hertz if we were finding the unit. If we're given units, we'd given that. We also had the relationship between frequency and period. Frequency is the reciprocal of the period. Remember, period is going to be measured in seconds. And remember, that's the time for a single wave to pass a given point. That's why frequency is per second or hertz. And then finally, for wave speed through a string, rope, cord, or other connector, V equals the square root of F sub t over mu. V equals the square root of F sub t over mu. Of course, F sub t is force of tension. That's measured in newtons. Do you remember what mu stands for? Not coefficient of friction. That was a long time ago. Practically speaking, it's the thickness. It's mass per unit length. So it's the number of kilograms per meter. So if something is 3 meters long and it weighs 3 kilograms, that's 1 kilogram per meter. Usually strings are a lot smaller than that, okay? So you've got, you'd have to have a lot of meters and meters and meters of coiled up string to even weigh to give you a mass of a kilogram. So usually it's a very small value here, but kilograms per meter, mass per unit length, practically speaking, the thickness of the wire. These are the 3 equations to know from chapter 16. Not a lot of math there. Chapter 17. Put a star next to this. This is where the math is primarily going to come from. We did a lot more math dealing with sound than we did with any of the other chapters in this set. Starting with the speed of sound in air. Remember, it's 331.5 meters per second if it's 0 degrees Celsius. But if you increase the temperature Celsius or decrease the temperature Celsius, the speed of sound changes. According to the square root of T sub C plus 273, so you get the Kelvin temperature, and then divide by the 273 to get the relative Kelvin temperature. The square root of that times 331.5 gives you your speed of sound in air. We could use the speed of sound in air to help us do some math related to the shift in frequency of sound as an object is moving or an observer is moving. We call that the Doppler effect. And Doppler effect is mathematically that the observed frequency equals the frequency the source actually emits times the ratio of, well, first of all, we take the sum of the speed of sound in air and the speed that the observer is traveling at, and compare that to the speed of sound in air minus the velocity of the source. So again, this shifted frequency is Doppler effect. Sure you know that. And of course, these two kind of connect because the V sub air comes back to this. A couple of other equations that connect. I1R1 squared equals I2R2 squared. Intensity at different distances, remember. The further you are from the source of the sound, the less intense it sounds. You think about guys like George Whitefield. Remember hearing stories about him when he was preaching during the Great Awakening, and he could preach to a crowd of 20,000 people, no microphones, no speakers. They could still hear him. I mean, granted, the people were standing around, but still, 20,000 people, how far away did you have to be? And they could still hear him. You wonder how loud he sounded to the people who were right down front. Did they have earplugs? I don't know. Have they been invented? I don't know. But I1R1 squared equals I2R2 squared. The thing is, though, the human ear doesn't perceive intensity. It perceives loudness. So remember, the way we had to work problems was we would be given a loudness, change it to intensity, so we could plug it into the equation. Of course, that would also give us an intensity. And then we'd take that intensity, we've got to convert that back into loudness using the equation beta equals 10 times the log of I over I sub naught. Remember that I sub 0 has what value?
9e-12.
Watts per meter squared. So remember, intensity will be watts per meter squared. Remember, the loudness, we'll measure that in decibels. And that's the reason for the 10, by the way, it gives you decibels. If not for the 10, you'd be having bells instead. So these two equations often used together, these two equations often used together. Questions on these equations, pardon. All right, then chapter 18, already looked at it earlier this hour, but there's really only the two equations for energy, E equals HF and E equals H times C over lambda. Now, of course, if given the energy, finding frequency, or if given the energy, finding lambda, the wavelength. Remember, energy is going to be measured in joules. Remember that the H, Planck's constant, 6.63 e negative 34 joules times seconds. And if you end up using this equation, remember that the C is 3.0 E8 meters per second. So obviously tonight, as you get ready to study for your test, the terms, they're in bold, they're in your notes, study those over. I would suggest studying in the notes as opposed to the book, but you could do either. These are the equations to focus on if you want to go back and look at problems that we've done. I believe you had a handout for chapter 17, which could be very useful tonight as you review over for this test. Chapter 16, I think there was a little, like a 2-problem handout. There's not a lot from chapter 16, admittedly. Chapter 18, we've done a few problems there in the textbook, but chapter 17 is where the bulk of your math will come from on the test coming up on Wednesday in lesson 127. Any questions at all on that? All right. Well, tomorrow we'll be reviewing, and Wednesday is your test.